welcome everyone. My name's Clint, K0GR, and I agreed to do a talk on 3D design. And so we'll talk a little bit about the 3D printer, but really we're going to talk about the design part of it. And so I brought some stuff that I've printed that I've designed myself. And so there's a lot of stuff online that you can grab and print. And I've done some of that, but I've really enjoyed the part where I've designed my own things. So this, I'm just going to do a quick tour on the computer here and show you some stuff. This is like the first thing I designed. It's a bit holder for Dremel's bits, and then it goes in the top of a toolbox. So I now have a toolbox that holds the Dremel on the bottom, and the tray at top holds the bits. And so that was like the first thing I ever learned how to design. This is the mount for my control head on my truck. So I think you should be able to see this online. Basically, this part was attached to the front of my pickup that under the radio until 5 minutes before I walked in here, and you can just yank on it really hard, and the clips come loose, and then it comes off. And so this thing over here, maybe, like there. So it's basically the airbag light and the four-way flasher button under the radio, and I put 2 screws through it. And so it's I bought another one of these for like $12, and I got it at home. So if I decide that I don't want the hole in my dash, I just pull this piece off and put the switch in the other set, and so that's how I mount the radio to my dash. So I designed that. Let's see. This is my Ballon I've shown before to the club. And so there's a wound toroid, and so that's up here. And so there's an empty one, which is the orange one that I haven't built out yet. This is going to be a 20-meter dipole. And then this is my link dipole that has the Ballon full, and then some of the other parts like the little end insulators that I'm going to demonstrate how I designed. So that's pretty fun. I've used the heck out of this thing, and it's worked really well. Very rugged, and it's got a sleeve on the top to hold it sits on top of my fishing rod that I put up 20 feet in the air. And so I don't have to hang it from the top of the fishing rod. It just sits on the end. So that works really well for me. Okay, next thing. This goofy looking thing is, actually, I'm going to grab the mouse. This is going to be a lot easier to do with the mouse. No. Well, maybe new battery. There we go. So all of these things in this program are manipulable, so you can kind of turn them around and look in the ends, kind of see how things look. And so what this was, if you haven't figured it out, is the bracket that I made the Barbie swing. And so it's got the sleeves to hold those little wooden posts. My daughter, that was her Christmas present this year, and Barbie does swing a little. So, yep. So not radio related, but it was still kind of fun to design. This thing was I needed to connect a piece of shop vac hose, and so that turned into this. And so you can just couple 2 pieces of shop vac hose together and make the hose longer. Let's see. That was the watering can diverter that I had lost the end of, so I made another one. This guy is, it looks pretty big, but it's actually really small. You zoom out, what it is on the end of my ropes. You can buy line locks, but I thought, why not make my own? So that's what this little guy is. I can print my own line locks. I actually have to change the nozzle and put a smaller nozzle on to get enough detail. Otherwise, it doesn't work. Something that small, it's kind of weird to print. I made a wrench to tighten the nut on the BNC on the dipole, so I had to make my own wrench. I made my name tag this afternoon, actually. So it was kind of fun to just see if I could do it. Okay, so those are just some of the things you can print. While we are waiting, or while I'm talking, I'm going to start the printer. And so this is my Prusa Mark IV. It's pretty new. They have an updated version. I might buy the upgrade parts for it, but one of the nice things about these is that it self-levels itself. And so you're going to see as it starts moving, it'll do all its checks. It'll run into the side. It'll run into the bed. And it's got sensors so it knows where everything is. So I don't have to like level the bed or anything. It just kind of does its own thing. And it's got sensors. It knows that there's filament in here. So it's pretty idiot proof. It's been real nice. I actually built this as a kit. So I just ordered all the parts, and it took a while to put it all together. But I understand how it goes together, and it was real fun. So we're just going to let that run. So the real thing I wanted to show tonight was Fusion 360. It is a CAD Design, maybe. It's kind of a lot of weird names, product design software. There's other versions out there. There's Tinkercad, and what's the other one, Paul, that is real popular? Yeah. 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 So you can do it. There's a lot of different ones. Those are all the free ones. This one is what a lot of the professionals are using, but if you stick to a non-commercial use, home use, then they let you have this for free. Don't ever pay them and then expect to come back, because Paul learned the hard way. They won't let you go back. They'll lock you out. So it's only free until you give them a little money, and then they won't let you come back to the free version. So I chose this because I looked online. Everybody said if you're going to learn something, this is the best one to learn. It's got the most features. There's very limited things that it won't do because it's locked out of the free version. I only have 10 editable projects at a time. I'm only working on one thing at a time, so having 9 others sitting there able to be edited isn't a big deal. So one of the things I wanted to design was a ring to go on my fiberglass fishing pole so that I could guy it. So about halfway up, I want to guy it. I've measured it with my calipers. When I do a design, I pretty much sit these calipers right next to the keyboard, and I'm just constantly looking at them, even if I'm just going like this and saying, I want about a 3 millimeter hole. I use these a lot when I'm doing a design. So to start with this, about the first thing you always want to do is, let's see, go to a folder. I'm going to go to the SCART demo folder and the meeting demo, and I'm going to create a new component. The reason why you do that is just so that if you start building pieces together, it kind of keeps track. And most of the things I'm doing are one item, so there's only one component, but it's just kind of the good housekeeping to do that. So we're going to call this guy ring demo. Okay, so now I got my guy ring demo, and the first thing I need to do is create a sketch. So what you do is you draw everything in 2 dimensions, and then you start giving it shape. And so I've got multiple planes I can work on. I'm just going to work on the XY plane here, so it tilts it. So I'm looking straight down from above at it. And the first thing I need to do is draw some circles. So grab my circle tool. I'm just going to drop it right in the center. And I know that the mast that I'm working with measured out about 24.1 millimeters. So I'm going to make this thing, just draw a circle, and then, oops. Oh, let me use the real mouse. That's one problem. Let me get rid of this thing, Paul. There we go. Stay out of my way. Okay. So I'm going to start with a circle, and I'm just going to say that it's 24.25. And then I need another circle. That's the inner hole. I'm going to draw another circle. That is about 42 millimeters. So I've got my two circles now. Let's see, I need to put a center line in for the circle. The center line just helps you constrain stuff. And so you use the other lines for things, because I need to draw another circle for where the holes for the string go. So I'm going to create a line, and I'm going to start it in the center here. So if I can put a line wherever, but if I hover on this center point and then drag along the line, it's going to lock it to this line. So I'm just going to throw this center line in here like this. Oops, I didn't. Let's see. I call it a center line. Come on. Okay. Okay, so that's my center line. So now I need to draw another circle where the hole goes. And so now I can use this center line to kind of lock it and make sure it's on the right point. So I'm going to make the hole like 4 millimeters. So I type 4 and enter. I get this 4. Now this circle isn't really what they call constrained, in the sense that I can grab a hold of it. I can move it around. See, I dropped it on that center line, so it's stuck to the center line. That's what this little black symbol is here. But it's moving around on me, and I need to lock it in somewhere. So I need to dimension this to tell it where I want that on the circle. So if this circle is 42 millimeters, and this is going to give me the placement off the radius of the center. So half of 42 is 21. I want about 3 millimeters between the edge of the hole and the edge of the circle. So that gets me down to 18. Then the circle's 4 millimeters, so half of 4 is 2. So 18 minus 2 gets me 16. So I'm going to use the... oh, there's less options here. Where did it go? Things look different on this smaller screen. Oh, I know what the problem is. Get rid of this. I'll get rid of this thing. Ah, that's better. Okay, there we go. Sketch dimension. So I'm going to take the center of this circle, and I'm going to drop it to the center of this circle. I'm going to pull this down here, and I'm going to tell it I want it to be 16, and it shifts it over. So that gives me this 3 millimeters from edge to edge. A little closer here, but that's okay. I don't need the room. And so there's my circle. Now, the next thing I need to do is I need to make 3 holes. So I can start drawing them in and guess where they go, or you can use the tool called a circular pattern. And I say I want that one, and my center point is right there, and it defaulted to 3. You can put 4 or 5. You can just start cranking circles in here if you want. I only really need 3 for my 3 guy lines, and it centers them around that center axis that I clicked right there. So there's my 3 circles. Okay, so I think I've got all the drawings I need for this, and so now I need to actually make it 3-dimensional. So if I click on the button here, you can kind of see if I tilt it at an angle, it's still this flat thing. There's no shape to it. And so one of the coolest buttons to push is to, I just finished the sketch. So then you get this option called extrude. And extrude gives things depth. So I need to click on what it is I want to extrude. So I'm going to extrude that piece and this piece. I don't want to click this circle because I want it to leave me a hole. I don't want to click in the middle. And so I need to just have these two halves. The reason why these are halves and not one piece is because I drew that center line across the middle of them. So it divided them up. So I had to click both of them. And so you can put a number in here. Positive goes up, negative goes down. You can just click and drag. And all of a sudden, it starts to become a thing. And so I think I don't need this thing to be super firm. So maybe like 4 millimeters sounds like a good number. You can type in here and get all kinds of different things. So you have to watch, like if you have if you join in something else, you'll have this join thing. You can cut holes and stuff if you want. But anyway, so now it's going to have this shape. And when I hit OK, now I've got a thing, right? And so when I start moving it around, it's its actual part now. And so the only thing I really want to do now is I don't really like printing real sharp edges. I think they look kind of cheap and they don't usually work, and sometimes they'll peel off. So I like to fillet everything. So I'm going to hit the fillet tool, which basically just rounds the edge off, and I'm going to click on the upper surface. And then if you can kind of see here, as I'm clicking around, all of a sudden you kind of get like the shadow of the piece underneath. So now I've clicked the bottom. So if you look, you can see I've got the top and the bottom selected. Nope, I got the edge selected. Never mind. So let me go underneath here, click the bottom. And so it says I've got two faces selected. And the tangent weight, I can fillet this by quite a bit. So let's see, there's 1. And I don't really need it to look like a donut, so I'm actually going to make it 0.5. And that's kind of what I was going for. So the holes where the string goes through isn't going to be super sharp. The edges are just a little bit rounded off. I think it'll look pretty nice. So this is ready to print. So I've just designed my thing that quickly and what I wanted to make. So I'm going to save my project, and it's going to give you can do a lot of versioning. And so I can just put draft 1 on this and save it. And then I'm going to go up here and I'm going to go to export. And pretty standard for all 3D printing is we're using STL files. And so that's what this is going to come out as. I'm going to put it in my Fusion 360 STL. I don't want to call it draft 1 though. I want to call it guy ring demo. I'm going to export it. Okay, so now it's out. So let's see. Next thing we want is to go to the Fusion 360 STL folder I saved, and there's my file. And so if I click on it, it's going to open what's called Prusa Slicer. There's a lot of slicers out there, different companies. Prusa Slicer is really one of the best. Other companies have kind of forked it because it's open source and have done things with it. I'm not really going to get too deep into the slicing part, but just know that there's my product. You can zoom in, you can kind of move it around. You always want to print it on a flat surface. So it came in on its flat surface, but you can move it around. You can, try to print it on its side if you wanted for some reason. Pretty much right now, it's kind of just giving me the option to put it on its face or on its back. So don't really need to do anything with that. Let's see, I've got PETG in here for my filament. I'm going to have it a little stronger than 15% infill. I'm going to make it 30% infill. And what that is just besides the outer layers, it's sort of hollow. And so you typically put some sort of grid or circular pattern or whatever inside to kind of make it more rigid and fill some of the space. But you don't want to make it 100% because that's just going to waste plastic because, you don't need it that strong. And so 15 to 30% is usually where I keep my stuff. And so let's see. I don't think there's anything else I really need to change. Let me check my settings here. I'm going to make it have 3 perimeters. Basically, the perimeters are like the shell layers, how many actual solid layers are going to be on the outside. And then it's defaulted to 5 on the top and 3 on the bottom when it prints. I like to have my seams sort of random. That way you don't get a seam on the edge. It kind of randomly puts where the seams are, and then they blend in. So I think that'll work. I'll go back to my platter and I hit slice now. And just like that, it's done slicing. And so you can pull down through here and you can start to see where the infill pattern is there. And so that's the 30%. If I had chose 15, the squares were going to be a little bigger in there. And so that's really how that pattern, how it looks. And so you get down to like the first layer and it prints like that, and it prints another layer. And you can see how the hole gets bigger as it goes up because the bottom of it's tapered. And then you get the 3D infill, and then it'll slap that first layer in there and then cover it up till you get to the top. And so it's kind of got a color code here that the perimeters are yellow, the exterior perimeters are orange, infill is red. So you kind of can use this to kind of guide you. Another neat thing to look at is it's going to cost us 10 cents to print this, and it's going to take 10 minutes in normal mode. So pretty simple to do. One thing I just remembered, I printed this thing out and it didn't actually fit the mast because of the tolerances of the printer. When you print it, it squishes a little bit, and so it was a tight fit. So I'm actually going to go back to Fusion and say I need to fix this. But because this is what's called parametric, meaning there's a timeline down here of all the steps I've taken, I can go back in, edit my drawing. Instead of 24.25, I'm just going to make it 24.5. The hole is going to get slightly larger. And when I hit finish sketch, it recalculates everything back to this new size. So I've just that quickly made that hole bigger. Save it again as version 2.
It doesn't recenter those other circles.
It just goes right back to what I had done before, because the center had no impact on where those other holes were. They just stayed the same. My center hole just got slightly bigger by 1/4 of a millimeter. Yep. That's kind of when you design stuff, you figure out, if I might move this, I don't want to tie something else to it if I don't want it to move with that thing. And so you kind of play games with what things are tied to what. You want like this point to always be on this circle so that they move. And so now I'm just going to go ahead and export this again. And we're going to call this, what was the other one's name? Skyring Demo 2. Okay, that's out. And so the nice thing I can do is I can just take and drag this thing, drop it right in here. And now there's 2 of them. And so this is my new one. This is my old one. So I'm going to hit delete. And I'm going to pull it up front here so we can see it when it prints. And I'm going to slice it because all the settings are still the same. And then I'm going to export the G code. And basically the G code is the code that tells the printer X, Y, Z, and how much temperature and how much filament to spit out. All of those commands are in the G code. So I'm going to export my G code to my Mark IV G code folder. And it says it's 0.4 for my nozzle. It's 0.2 layer height. It's PET G. It's a Mark IV printer. It's going to take 10 minutes. So that's just kind of the standard naming convention. I'm going to save that. Okay, so if I was at home and on my network, the printer has Wi-Fi, I can just pull up the browser and drop the printer, the file into the printer. Since I don't have that, I'm going to have to pull the stick. But lo and behold, we've got some items that we can pull off. And so they stick down, so the sheet's flexible. So you just kind of flex it and they fall right off. And then it magnets on. So that works pretty well. And so now we have 2 more of the little things that we were looking at before. So It's got a little bit of waste that comes off every time and it purges the nozzle. So I need my memory stick. Okay. So go to my G code, guy ring demo, drop it in here. There's a file with the same name because I already created one of these, so I'm just gonna do this. Let's see. Oh. Did I do that wrong? I think I did. All right, I'll just export it again. So I'm going to copy this, and then I'm going to go to my card. Oh, get me out of here. Paste. Okay, what's on here? Plug it in, and the printer just says, oh, there's a new file. I see it. Do you want to print it? And so I can just hit print. And I don't want new firmware. And so now it's just going to go. So, and we'll print that while we'll do another design. Okay. So that's kind of the start to finish process of doing something. So let's go in here and let's create a new item. Let's redesign. Let me show you how I designed those little end insulators for the dipole. Okay, so we're going to call that dipole insulator. And okay, so then I'm going to create a sketch. Do it on the Z plane. Okay, so the first thing I'm going to do here is I'm going to draw a center line so that I can put the holes through that thing on that plane. So I got my line. I want a center line right here. Just draw a big line. Okay. Then I'm going to create a circle. The bigger hole in that little guy that we just printed is 7 millimeters. So that's pretty small. Let's zoom in here. I'm going to draw another circle somewhere. And the small hole is 3 millimeters. But I never told it what relationship these two have. And so I'm going to dimension that so that center from that hole to that hole is 24 millimeters. So that spaces them out the right spacing. Okay, now I need some more center lines to draw some more lines. So line, center line. I'm going to kind of start down here and draw a line like this. Start down here. Draw a line like that. So I got 2 more center lines. I'm going to draw some regular lines. So just a regular line. I want something that starts kind of up here and come the kind of angles down like this. And since I've got it on this line, it's kind of locking it in there. You can kind of see it jump at that blue X. So I want something like that. So I've got a line. And then I need another line that's kind of come off of this point and come down here somewhere to kind of make the point. The reason why I have those pointed is that as you're dragging the wire through the grass or through a tree, if it's pointed, it's not going to hang up as much. So I figured out instead of just rounding it off, I put a point on it. It tends to flow a little better. So I'm going to put another line out here and it's going to be pointed. Okay, so those doesn't look really that great. So let's dimension it. Let's go from this point down to here. And again, if I look at a 7 millimeter hole, half of that's 3.5. And if I want 3 inches around the hole, that's 6.5. So I'm going to put 6.5 on here for that. Oh, I need to constrain this line to, no. Try that again. At that point, be on, well, let's see. How do I do this? I don't remember what button to push. Well, it worked fine earlier. This is the part that you kind of struggle with. Why doesn't that line stay here? So let's see. I want to constrain that to, I think it's coincidental. Well, anyway, let's try doing it this way. Let's take that point. And since that's 3, so I want 1.5, half the circle plus another. So I want this to be 4.5. And then let's see if it'll let me do it now. Here to there. Oh, I already got it at 6. Okay, it's good. That's 6, which is, I want this to be 6.5. That was my problem, was that number was already there. Sometimes you get things double labeled and you lose track of why is it not working. And it's because I had labeled it twice. And then I need this point here, come back to this point, and that's way too big. Let's go like 7. That looks a little better for the point. Okay, so I've got the 2 halves, and I need to make it duplicate. So they've got a mirror function. So I can mirror these 2 lines, and it's going to mirror line, or the pivot point is this center line that I drew. Oop. Don't want to mirror that. Select this point, and now I've got the lines flipped over. So I've got the pair. Okay, I need to make the curve on the back. So here we can do the an arc, and I'm going to make a tangent arc. So I'm going to grab this point, and I'm going to grab that point, and it makes a nice curve that tangents off the end of that line. So it makes a nice even curve there. I don't want this thing to be really sharp, and I want this corner to be a little smoother. So I can use the fillet in this point and modify these. So I can use the fillet tool, click that point, and click that point, and then you can start adjusting. Oops, a little bigger here. Okay, so I really don't need it to be crazy curved, so we're just going to say 2 for that one, and that one. Enter, and then we'll do another fillet, and we'll just round this point here off. So we'll grab these 2 lines, and that one, I don't want it to be quite that round. I want it to have a little point, so I'm going to say 1.5. And so now we've got that shape, and so it's starting to look like something. Okay, so I think we're ready to extrude. So again, there's another way you can do this. You can even right-click on things and do extrude. You can do a push-pull. I got to grab all my pieces, and then I can do a Press pull. No, it's going to make me select them again. Okay. And if I look like this, I can start seeing how I can start pulling this thing and making it get big or go the other way. And you can even do it like symmetric. So you can do symmetric. And so it goes both ways. And so I'm going to make the distance, I want to make it about 5 millimeters. So I'm going to make it 2.5. And it's a new body. And so there we go. So now that's my new thing. And so we can, again, fill it. Not the circle, the top and the bottom. So I've got both of those selected. At the bottom edge and the top surface, it works the same. And let's just do like 0.5 on that one. And so you can see it's got nice curves to it. So it's not going to be real sharp. And, for fun, let's go back. We can add some text to this. So I can go to create text. I'm just going to draw a box in here. Come on. And put my name in there. I like Arial Narrow as my font. 3. No, 5. Yep, and I'm going to center it and hit OK. So the neat thing about this is I can't see it, but if I turn off I can turn on the sketch and turn off the body, I can grab that and turn it back on, and I can extrude that font. And so it sets up, I can cut it out of the inside. So it's now like a hole in there. Which is a little bit weird in this particular design, because why would you want it to be where am I doing here? Here. I always hit the home button and it goes back to where it's supposed to look. I don't really want this my call sign cut out of the metal. It's going to weaken it. So I can go in here and double click on this guy and I can edit it. And instead of cut, I can make it join. So now it's going to add this to this. And I don't need it to be 4 high. I can make it 3 high. And so it's 2.5 itself on either side. So that was 5. And if I say another 3, that'll make the lettering like 0.5 millimeter high is what that's going to look like. So I can turn the sketch back off. So there's our item that I've designed. And so you can see it's got depth and it's got my call sign. And we're ready to print this. So I'm going to save this thing. And I don't want to mess with it. It's on everything else, but I have to go copy paste it in here. I can't remember the shortcut to type that in. So it's what? All right, we'll try it. Let's see if this program will play nice. So again, because it's parametric, I can go back into this phase of it and type Alt 216. Huh? What's Alt Shift? Okay. That is not it. No, it's just giving me crazy stuff. Sorry, guys. You're going to have to copy paste it out of Word or something into this. I've done it before. All my other stuff has my call sign on it. But yeah, I'm just going to have to get a new call. Okay, so we can save this as draft, whatever I want to call it. And then again, we would go in and export it. And that's how we got the little black things. So the thing we have designed is done. The little ring. And so got a little bit of extra filament that squirted off, and I can just usually pull that off or take the heat gun to it and bake it off. But it's ready to go. So perfect size to my antenna or my mast. That was all I was going to cover tonight. Those of you at home, you can see that it came out just fine. You want to pass this around? Yep.
Still warm?
Oh yeah, it's got a little heat. Not like burning me, but I mean it's not room temperature. I got a few more because I practiced. So, can you tell me which one is the smaller one? Which one is a quarter of a millimeter smaller? Yeah, there's one of those that's a quarter of a millimeter smaller. So, yeah, and then there's the little ones. Yeah, here's the other ones we made earlier.
Okay.
So, other questions? Mike? You can adjust it. So if I put my 2.5 millimeter or 0.25 millimeter nozzle in, I think I can get the layers down to like 0.07. So they're pretty darn thin if I really wanted to. And that's what I was doing when I was making those line locks, because just the way that's got to be just super precise. It prints really slow, and it's got to be real thin layers in that small nozzle, so it makes the sharper points to grab the line. And then if I have like a 0.6 nozzle, and so you can make the layer, almost 0.6 millimeters. So it really prints fast if you crank up the bigger nozzle and the bigger layer heights. So the nozzle that most printers use is 0.4. And if I go to Prusa Slicer, there's my nozzle. I've got a 0.25 and a 0.6 nozzle. And then in this particular nozzle, I can do 0.1 up to 0.2 of adjustment there. So I can change that. And you can do fast, or you can do structural if you want it to be just slightly stronger. We're talking minutes at most on a big print, the difference. Yeah, Ted. I've got a 7-year-old laptop that I've been running this, and it's fine, but it wouldn't also do Teams at the same time. So I borrowed my wife's laptop, which is newer. But I've got a couple of laptops that are Windows 10, and they've been fine, doing it. Yeah.
So I know not all of the filament types are adequate for outdoor UV.
Yep.
Breakdown in UV. So have you printed anything with PETG that's been outside in the sunlight kind of permanently?
This thing has been on the dash of my pickup. It's out of PETG, and it's been on the dash of my pickup for 6 months, I'd say. And it's just as new. PETG is essentially just pop bottles, is all that is. It's the same plastic. In theory, there's people out collecting pop bottles, melting them down, making their own filament, if they really are cheap and crazy. Yeah. So PLA is corn plastic. That's kind of what everybody starts with because it's cheap and it's pretty forgiving. But I stopped buying PLA just because most everything I print, I want to have it rugged enough that it can go outside. PETG is a little more flexible. PLA is a little stiffer, so it's a little more brittle. So depending on what you're doing, like yeah. So I haven't gotten into the exotic stuff. Like I've got a roll of what's called TPU, which is going to be rubbery. So when I print it, it's going to be moldable. So that's going to be interesting. I wonder if I can make like rubber caps for stuff, or I want to make a sleeve for a water bottle. See if I can do that. One thing I forgot that I brought, this mention, I didn't design these, but these things are really handy. Essentially, they're just radius gauges. So I've got anywhere from 2 millimeter radius up to, looks like 100. So, you know, when I was designing the car thing, I had to figure out what the radius of this thing was so that I could print it in my design. So I think it was like 63 millimeters was the radius of this curve that I had to match. So these things have been kind of handy. Just I printed a whole bunch of them off. And so they're white letters because what I did was I printed it to a certain point that was black. I switched to white filament, printed a couple layers where the numbers were, switched back to black and finished it off. And so the number whites are inset in there, so you get a little texture to it. And so that's how I made it colored. And that's how I made my badge too, was I just printed a white square, a rectangle, and then flipped black filament and then put another 0.5 millimeter on top. Yep. It's real easy. You can just drag it down here. So I wanted this thing to be about half white. You could just go in here and right click and hit add color change. You can add custom G code. You can add a pause. So I've used pause because I've stopped things and embedded magnets and then reprinted, and it encapsulates a magnet or a nut to hide things. So there's different tools you can do to do stuff. So here, you know, it's just saying, oh, you want green and orange. And so you can kind of see how it's paused and it, you know, it says, hey, there's a color change in there. Yep. Right. Yep. Yes. Let me show you some more projects here. Okay. So this is the dipole balun thing, right? And so when I slice it, it takes a little longer down here to crank on that because it's got to do a lot more work. But it makes it makes all these supports. So this is what I call organic supports. So it looks like little trees. And so you can kind of start peeling down the layers. You can start seeing where it builds these little trees up off the bottom to hold the lid up. And so then it builds little trees on the inside of that little tube on the back to hold the top of it up. So it's kind of neat. And then they just break right off once you're done. So it works pretty slick. Depends. You try to put them where you don't really notice them. And so if you look at this orange thing, I actually find the heat gun is not enough heat to superheat the outside, smooth it off before it starts to heat the whole thing up and it starts to creep. So I actually find that a little torch lighter and I just kind of kiss it across, takes care of a quick, anything sticking up gets super hot and falls, but the whole model doesn't really heat to the core where it starts to deform. But yeah, I've done that on the edges of this where it was held up. The inside you can feel in here after, and it's rough. I mean, there's some significant roughage, but it's just going to have that balance sitting in the little toroid with the wire wrap sitting in there, so it doesn't matter in that case. The reason why I printed it that way was I wanted this surface to be really smooth from the print bed, so that when I printed the lid, the two of them mated and were very smooth to each other. I don't intend this to be waterproof. I didn't need it to be waterproof, so I didn't print like any lips. I'm not planning on sealing it up. I printed some weep holes, so if the water does get in it, it can run out. So, yeah. Anything else? This does, yes. There's little brass. I think these are 2mm heat set inserts. So essentially, it's little brass things with threads on the inside, and you can use as a regular soldering iron. But I have a little adapter that I put on the end, and you heat the gun up, and you just set it on there and push it in, and you stop when it gets about level. And so, when you order the things, they tell you how big of a hole to make, so that it will fit in. If you make the hole too small, then you get a little oozing on the top, and you just clean that off with a knife. So it's not been a big deal. So, yep. Oh yeah, yeah. I've done a few website stuff. I printed some. I'm gonna make a Lego vase or a Lego wreath. It's 6 pieces of Lego that are gonna be this big total. So each leaf is this big, when normally the Lego leaves are this big. So it's about as big as the print bed for each leaf of Lego. I made a Lego vase for my wife because she has some flowers. Um, Oh, I printed a Rocktopus, which is an octopus with articulating arms and Dwayne the Rock Johnson's head on it. So it's a Rocktopus. My daughter picked it out. I printed a little bitty soccer goal and some shoes for her fingers so she can play soccer with her fingers. You know, I mean, just weird stuff. Uh, so yeah, there's just Thingiverse and Printables are two of the big websites that have tons of stuff. Uh, and so sometimes I'll go there and I'll get inspiration and then kind of make my own off of that.
About that.
That. Oh, right. Yes. Yeah, the Rocktopus. I know, right? Yep. It yeah. This one with the kit was $800. It's another couple hundred to buy the one put together. And then I've got the enclosure also that I need to finish building. So then you can print the smelly stuff. The some of the stuff that's really hard or flexible, they off gas. And so you have to have it in an enclosure and suck the air through a charcoal filter or vent it to the outside. Some of them are really sensitive to the temperature that they print in. And so you have to have an enclosure to sort of keep that temperature inside so that it doesn't try to delaminate from the bed. Um, yeah, the bed gets hot. I think I read somewhere somebody grilled a sandwich on it. So, I mean, not my thing, but I suppose. Oh, this is a weird one. You're asking me about stuff I've. Oh, I'm in the wrong folder here. STL downloads. So we had a GoPro at work. And so I had to print a frame. Oh, that's a ball. Never mind. But I printed a frame for the GoPro so that I could still plug it in to an external battery pack, and I put it on the tower that we've seen at Field Day, and we filmed the conservation practice going in over 2 days, just with a GoPro up on the tower. So that was kind of interesting. I was gonna see if I could find the Rocktopus for you guys because, you know, I printed a little knob cover for my Baofeng. I printed a dog sled cookie cutter. My daughter wanted a dog sled. Oh, there's the ghost walking dog. There's some cool projects that you can do. I'm not seeing the
Was your
the rock bus.
powerful adapter for the IC 7300?
Yeah, that was when I found somebody had designed it, and they actually charged like $10 or something for the design, and so I paid them the $10 to download it because I could have done it myself, but for $10, what's my time worth? And so it basically takes, and you plug you push the connector on the radio inside and plug in an adapter, and then you mount a power pole to the back of the radio using these two 3D parts that you clamp on the back. And so that worked out really well. This is, I don't know. I printed a lithograph. So this is a picture of my daughter that it's variable thicknesses. So when you hang it in the window, it looks like a black and white photo because the dark spots are thicker and it's real thin where it's lighter. So that was made that for my wife for Christmas. Let's see. Is there other stuff I had? Oh yeah, she wanted a ghost walking a dog, so we printed that. That's actually printed in 3D filament or glow in the dark filament, so it glows in the dark. So yeah, there's just all kinds of crazy stuff you can find online and print. You know, this your imagination. Yeah. Yep. Thingiverse. Mm-hmm.
Dozens and dozens of things for each brand. Are they universally usable by different printers, or do you have to check and make sure it's something that will work for your software?
The STL is a standard design, and then the G code is custom to my printer. So in theory, I could take an STL and load it into a CNC machine and mill it out of a block of wood and make the same thing that I'm printing. Or they have other kinds of printers where it builds with lasers, and so you use laser or light infused to basically take this liquid and they shoot lasers at it, and you start building things as the bed pulls away. It's building it underneath, and so instead of printing the hot liquid, it's actually creating it out of using UV light and stuff. It's weird stuff. I've never been around one of those, but yeah. So yeah, STL files are is the standard for a lot of stuff. Yep. So I'm just not seeing the Rocktopus. Sorry, I'll have to look that up. Oh, she had me print her a watch holder so she can charge her smartwatch. It has a little stand with the charger mounts in it because it was falling off the charger. So yeah. So yeah. Any other questions? Okay. That's it.